Follow along as we go over the January 2024 Chemistry Regents exam. Now, we're going to go through in this video Part A. There are 4 parts to the exam. Part A and B-1 are the multiple choice. That's 50 questions out of 85. And then Part B2 and Part C are your short answer. Part A is 30 questions, which we're going to start going over now. I would suggest having a pen and pencil at the ready. Even better, if you go on the New York State Regents website and take a look at the exam yourself, work through the questions, and come back for the answers and explanations. I think you're going to get a lot out of this. The more you practice for Regents exams, the better you're going to do. And with that, let's get started. Part A, which is 30 questions, in my opinion, this is the easiest part of the test. It's all definitions and facts. If there's anything that you don't remember as you go through this, in other words, you get the question wrong, write it down, do something with the fact that you got it wrong so you won't get it wrong in the future. This January 2024 Regents exam, I thought overall was very straightforward. I didn't find any really new questions with a twist. They are in the future, not now, but a couple years from now, they're going to be changing formats of exams. So I think that the Regents exams right now are going to be very straightforward. This should be very similar to what you end up going up against when you take the test. All right, so question 1 here, we're looking at the particles that surround the nucleus of a neon atom. Whether it's a neon atom or any other atom, we're talking about, of course, electrons, which is choice 1. For question 2, which conclusion was proposed as a result of the experiment during which some alpha particles were deflected while passing through a thin sheet of gold foil? Okay, so the proposed result, there were 2 results. That the atom is comprised of mostly empty space, which would mean you'd have a lot of alpha particles going through the foil, and the other was the deflections were the result of atoms having a small, dense, positive nucleus. Now, why positive? Well, alpha particles themselves are positive, and the nucleus being positive, when you have like charges, they're going to repel. And our answer here for question 2 is choice 2. For question 3, the mass of each proton and each neutron is approximately equal to. Well, we say that those 2 subatomic particles, which are found in the nucleus, give really the atom its mass. Electrons are about 1/2000-ish the mass of a proton or a neutron, and we call them AMUs, or New York State calls them Mu's, which is choice 3. For number 4, which statement describes the relationship between 2 electrons in an atom of magnesium in the ground state? Well, it turns out that for any atom, right, if I make an X and that's my nucleus, as the electrons are farther and farther away from the nucleus, they have more energy. And when you go ahead and you read through all of these, the answer is going to be choice 4, and that's because it says an electron in the 3rd shell, meaning further away from the nucleus, has a greater amount of energy than an electron in the 2nd shell, which is true. All the other ones work opposite. So choice 1, choice 2, and choice 3 are saying the opposite of choice 4. And again, the further away electrons are from the nucleus, the more energy they possess. For question 5, as an atom in the ground state changes to an atom in the excited state, right? So we have electrons moving further away from the nucleus, from ground state to excited state. The atom absorbs energy. Of course, from the excited state back to the ground state, they would release energy. All right, but in this case, it's talking about ground to excited. For number 6, which statement describes a chemical property of copper? Chemical properties mean what copper reacts with and what it doesn't react with. Physical properties are just descriptions of a substance. And with that, we can go through and cut off 1, 2, there you go, choice 3. So chemical properties, keywords here, reacts with. When you see that, obviously it's a chemical reaction. For number 7, at STP, 2 forms of solid carbon, diamond and graphite, have different properties because. This question shows up every Regents exam. This is all about this word called allotropes. That's when you have atoms of the same element, but they have a different structure, different arrangement of the atoms, so therefore different properties. They never use the word allotrope, but the allotrope question is always on the exam. And sure enough, here we have it all the way down to number 4, that diamond has a different crystal structure than graphite. All right, for question 8, which element in period 2 has the highest first ionization energy? This is the energy to knock out the electron furthest from the nucleus of an atom. Now, don't get lazy. You have a reference table, and this is the first time you're going to check that out. You're told about period 2. You could go right to the periodic table and go ahead and circle boron, lithium, neon, and nitrogen on the period 2 row or in the period 2 row. And the further you are to the right on the periodic table, the higher or the more energy it takes to knock the electrons out, which would be choice 3, which is the answer. You can also go to reference table S and actually find the first ionization energy numbers. And neon is going to have the highest value. Again, don't get lazy. Go to the reference table. Now, I also want to point out to you, in this type of question, you'll notice that they went ahead and gave you the words for the elements and not the symbols. They're not going to make it easy on you. If you go to the periodic table and are looking to figure out which element is closest to the right, you have to realize neon is Ne versus nitrogen, which is N. On reference table S again, you have the name and the symbol. So you never ever should spell something wrong or not be able to figure out what element it is. Moving on to question 9, which phrase describes a specific compound? If you have a compound, you have 2 or more atoms of elements that are quote unquote chemically combined. Okay, and in this case, the ratio does not vary. For example, water is H2O. You have 2 atoms of hydrogen and 1 atom of oxygen in a molecule. It's not going to change in a minute. It's not going to change 5 days from now. So it can't be 4. When you have different proportions in a mixture, right? That's a mixture, not a substance. It's not going to contain only one element. It's not a compound, and it's not going to be physically separated. The only answer here that makes sense for question 9 is choice 3, which really is part of the definition of a compound. All right, we're coming up to question 10 here. Which type of chemical formula shows the arrangement of atoms in a molecule? And there are different words in front of the word formula, and you do have to know the difference. I do want to mention to you, I did a whole bunch of shorts, YouTube shorts last year on all the different kind of terms and calculations, all kinds of things for you to review. So I would highly recommend you check out my YouTube page and my playlists. Of course, if you're here and you're still listening to me at question 10, you're dedicated into doing as best you can on this exam, and good for you. But check out more stuff I have on my channel. There's also other teachers that have some great channels as well. And again, good Good for you. I'm so happy that you're here. All right, so for question 10, we're looking for the formula that shows the arrangement of the atoms in a molecule. Okay, empirical formula is your lowest whole number ratio. Your general formula, again, well, that's kind of a general word, but that's not going to give you an arrangement. Your molecular formula, that's for all your covalently bonded compounds that are molecules like water, carbon dioxide, methane. The only answer here that makes sense at all is choice 4. All right, for question 11, a 2.5 liter sample of sulfur dioxide at STP and a 2.5 liter sample of carbon dioxide STP can be differentiated by comparing. Well, obviously it's not going to be volumes because they're both 2.5 liters. They're both also at standard temperature and pressure, so the temperature is not going to be different. They're both gases. That's not going to be different. The answer is their masses. If we go to question 12, which terms identify the two major categories of compounds? Again, terminology here, your definitions, your facts really come into play. We haven't done anything with any kind of mathematical equations, and we won't in part A. What we're looking for here, again, compounds. Covalent is a bond. Molecular has to do with the formula. It's not choice 1. Again, covalent is a bond. You can throw out choice 2 already. Ionic and molecular for categories of compounds is going to be your answer. And ionic and thermal, I didn't even mention it up here, but thermal makes no sense as far as a category of a compound. So 12 is choice 3. For question 13, which molecule of an element contains a multiple covalent bond? Bromine and fluorine are part of group 17, known as the halogens. 7 valence electrons, they only need one more to get their octet. They form single bonds between the pairs. Can't be those. Hydrogen only has one valence electron when it bonds with itself, right? It's sharing a pair of electrons between it. The only answer here it could be is oxygen. Now, oxygen is in group 16. Each oxygen atom has 6 valence electrons. It needs 2 more to feel like a noble gas type of electron configuration. When it bonds with itself, it double bonds. Nitrogen, N2, is our triple bond. For question 14, we're asked which molecule is symmetrical. It's going to look pretty much the same no matter how you look at it in both shape and distribution of charge. All right, so we're looking for something that is a non-polar molecule, right? All the electrons are flying around evenly. HCl, polar bond, polar molecule. It's linear. H2O, polar bonds, polar molecule, the bent shape. NH3, polar bonds, polar molecule. It's your pyramidal shape. CH4 has polar bonds, but the arrangement is a tetrahedral arrangement. Since all 4 bonds are the same, again, it has this symmetrical distribution of charge, and that is our answer, choice 4. For 15, what occurs when 2 atoms of bromine react to form a molecule of bromine? Well, when we have any type of bonding that is occurring, energy is released. Now, if it's the opposite, if you break a bond, then energy is absorbed. Okay? But if you form a bond, energy is released. 16, atoms of which element have the strongest attraction for electrons in a chemical bond? What they're asking for here is the term electronegativity. Electronegativity, once again, shows up for all the elements on reference table S. It's an atom's ability to pull the electrons towards the atom in a bond. Now, you might remember from class, your teacher saying fluorine is the most electronegative element that we have on the periodic table, and that is a fact, and that is our answer. But if you don't know, you're going to go to reference table S, you're going to find these four elements, look up the electronegativity values, and then figure out which one is the highest. Where 17 heat flows from an object at a temperature of 20 degrees Celsius to an object at a temperature always flows from hot to cold. So we're starting at 20. We're going to go lower. They didn't even make this a hard question. They didn't give us some in Kelvin and some in Celsius. The answer here is choice 1. For question 18, according to kinetic molecular theory, an ideal gas has particles with. Kinetic molecular theory typically is abbreviated as KMT. There are no real gases that are actually ideal. What we do is we model gases and we take out the fact that they have attractive forces and that they actually take up volume. And there you go. There's your answer, choice 3. For 19, which sample at STP contains the same number of atoms as 2 liters of helium at STP? If your temperature, your pressure, and your volume are the same, no matter what the gas is, it's going to have, in this case, the same number of atoms. You just have to be careful if they're talking atoms versus molecules, let's say. But we're talking about a noble gas, right? And then all of the choices are noble gases. The only thing we have to look for here is matching the volume, which is choice 2. For question 20, all chemical systems at equilibrium have equal. Now, again, just the fact it has equal rates, the forward and the reverse reactions are happening at equal rates at equilibrium. It is not concentrations. Concentrations will remain steady. It's the rates that will be equal, which is choice 3. All right, we're at that point where we're almost done. We got 10 questions left here. Hopefully you've gotten something out of this. Anything you got wrong, you're writing down, maybe rewrite it or reread it to yourself. You want to make sure that you're not making the same mistakes over and over again. And let's go ahead and continue with question 21. Which expression represents the heat of reaction for a chemical change? We're always going to deal with, this is called delta H. Delta, right, is that symbol for change, and it's always products minus reactants, which in this question is choice 2. I'm trying to circle it, and my little pencil thing isn't working. Now it's working. For 22, which phase change represents an increase in entropy? Again, another vocabulary word. Entropy has to do with the amount of disorder or randomness of the particles. Gases have the most entropy. Solids, of course, are much more uniform and they have the least amount of entropy. So what we're looking for is the phase change representing increase. What I tell my students is write an S, an L, and a G, and let's follow along with the choices. Liquid to gas is choice 1, right? Liquid to solid is choice 2. It's going in opposite directions. Gas to solid, that's choice 3. And gas to liquid is choice 4. Notice it's only choice 1 that's moving to the right. All the other ones are moving to the left. It's definitely choice 1. You're going from the atoms or molecules which are moving within one another to a gas where they're spread out, hence more entropy. That is choice 1. For 23, systems in nature tend to change toward. No matter what, we're talking lower energy and higher entropy. Again, entropy, the word disorder or randomness is used to describe entropy. So lower energy, so cross out 3 and 4, and then greater disorder, which is choice 2. For 24, which name represents a hydrocarbon? Hydrocarbon means you have a molecule that only contains hydrogen and carbon atoms. okay? And there are reference tables for organic. Let's go there. I want you to check this out. All right, we are here in the reference tables. The organic reference tables are table P, which give you the number of carbon atoms that relate to prefixes for the naming. Table Q, which gives you the three major groups of hydrocarbons: alkanes, alkenes, and alkynes. And then finally, table R, which have a list of our functional groups. So let me explain. Your functional groups are where you have carbons, hydrogens, and then some other element or elements besides those two. For example, halogens, oxygen, nitrogen, etc. For our hydrocarbons, the only difference between alkanes, alkenes, and alkynes is the number of bonds between two carbon atoms. When you go ahead and you name hydrocarbons, the prefix is going to be the number of atoms in the molecule. So Eth for the three examples here in reference table Q. And then the endings are whether or not you have all single bonds, whether or not you have one double bond, or whether or not you have one triple bond. And with the choices, because I remember it back at the test, there's going to be one with an ENE ending, and that's going to be our answer. Question 24, then our hydrocarbon is choice 1, which is 1-hexene, and it has everything to do with the ending being ENE. For choice 2, iodo means you have iodine also in the molecule. Hexanone is a ketone. That means you have oxygen in the molecule. And OL means you have an alcohol that has oxygen also. Here we are with the last 6 questions. I do want to mention, if you're not subscribed to my channel, please click the button. And if you like the video, please do that as well. I will be putting all the other parts to the exam out. You might like my style and you want to keep studying with it. If you don't, I would highly recommend you check out some other teachers' YouTube channels as well. The main thing is that you're putting in the work, you're doing great, and let's keep going. All right, for 25 here, what do we have? We have which process occurs at the anode in electrolytic cell. All right, you're going to have an anode and you're going to have a cathode. One, you're going to have oxidation. The other, you're going to have reduction. Now, these are all terms that you have to know what they mean. Oxidation is when an atom or an ion is losing electrons, and reduction is when you have an atom or ion gaining electrons. In electrochemistry, we're really taking a look at what's going on with the electrons within a chemical reaction. The easiest way to know which is oxidation and which is reduction is an ox red cat. I know it sounds silly, and I'm sure you've heard it before if you're still in class and not just reviewing on your own to take the test. An ox. So anode is oxidation, reduction is at the cathode. So in this case, it is choice 3. For 26, which formula represents an electrolyte? Now, an electrolyte is a substance that not only dissolves in water, but will break apart into ions. Water, when it dissolves in water, is not our answer. Carbon tetrachloride doesn't even want to dissolve in water because carbon tetrachloride is nonpolar, water is polar. Our answer here is choice 3. We have an acid. There is a reference table that lists common acids and common bases. Your common acids, your common bases, and your soluble salts are all electrolytes. Now, choice 4, which is glucose, is soluble in water, but it does not break apart into ions, so that is not our answer either. For 27, which formula represents an Arrhenius acid? Well, you're working with 2 acid-base theories here in Regents chemistry. In other words, how do I define an acid and how do I define a base? An areneous acid is a substance that when I put it in water, I get hydrogen ions, and an areneous base, when I put it in water, I get hydroxide ions. Well, if I look at my four choices here, the only choice where I'm going to get hydrogen ions being kind of not produced, they're already part of the molecule HCl, but getting pulled off into the ion form would be hydrochloric acid. And again, there is a list of acids on the reference tables. They are all areneous acids. There's also a list of common bases. All of the bases, the metal in OH, are areneous bases. The only base that's listed on the reference tables that is not an areneous base is ammonium chloride, or NH4OH. And that is the other acid-base theory. It's actually called Bronsted-Lowry theory, but for some reason New York State got rid of Bronsted-Lowry. Okay? All right. So let's work with 28 here. According to one acid-base theory, an acid is a substance. Now, this is the other theory about what's going on. Remember what a theory is. It's our best explanation as to what's happening. And since we can't see down to that atomic level, we go ahead and we come up with this explanation known as a theory. Areneous acid, you get H plus in solution. And this other acid-base theory, instead of looking at it as an H plus atom, we look at it as a hydrogen ion donor. And that is choice 2. 29, which nuclear emission has the greatest mass and ionizing power? There is on the reference table a list of nuclear particles, and your answer here is your alpha particle. An alpha particle consists of 2 protons and 2 neutrons that would be emitted from a radioactive isotope. So that is definitely not just the greatest mass, but if you were hit with alpha particles and you didn't have any protection, it could do the most damage to your cells. For question 30, which statement describes a benefit of nuclear reaction that occurs in a nuclear power plant? And that, let's see, we're looking for a benefit, so that's not going to be choice 1. Power plant reaction I can use, it's not about a benefit. It's not used for dating geological formations. For number 3, radioactive isotopes are stored for a very long time. Well, that's not a benefit. That's actually the opposite. It's finally choice 4. A large amount of energy is produced from a small amount of a radioisotope. With this, we end part A of the January 2024 test. I hope you got something out of it. Again, I hope you jotted some things down. I again highly recommend you check out some of the other videos on my channel, as well as some of the other teachers. Stay tuned. Hit the subscribe button. I'll be putting the other parts up very, very soon. And good luck.